All right, so today we're going to talk about the chain rule. And so the chain rule is used when you're taking the derivative of a composite function like this, like f of g of x. And so the derivative of a composite function would be the derivative of the outside function evaluated at the inside function times the derivative of the inside function. So it's really useful to be able to identify what is the outer function and inner function. So let's look at number one. So here we have this equation, and we're going to let u equal the inner function. So we're going to let u equal 5x plus 4. And if we do that, we can see y would equal u to the 3 over 2. Okay, so now if we take the derivative of y with respect to u, it would equal, right, applying the power rule, 3 over 2 u to the 1/2, right, because 3 over 2 minus 1 is a half. And then times the derivative of the inside function, right, u prime. So we're going to replace u with what our expression was in terms of x. So, okay, so dy dx this time, because now it will be with respect to x, is 3 over 2 times 5x plus 4 to the 1/2, and then times the derivative of u, which, so the derivative of 5x plus 4 is just 5. And we try to clean up what we can, so we can multiply 3 over 2 and 5 together to get 15 over 2 times 5x plus 4 to the 1/2. And we could change it to radical form also if necessary, but we'll leave it like that. Okay, so b, this is sine cubed of x. So this is the same as sine x to the third power. So what would be the inside function? Well, it would be sine of x, right? And the outside function would be x cubed or u cubed if we do u substitution. So we'll let u equal the inside function, sine x, and that way y would equal u to the third power if we rewrote that equation. Okay, so now if we take the derivative of y with respect to u, right, applying the power rule, it'd be 3u squared, and then the chain rule, right, because what's the derivative of the inside function? It would be cosine x. Or I didn't mean to write that yet because we're still writing it in terms of u, so it would just be times u prime. So now when we replace it with x, so dy dx would equal 3 times sine of x squared times the derivative of sine x, which is cosine x. Okay, and then we're good with that, or we could drop the parentheses and make it sine squared of x, like that. Okay, now if we look at part C, what's the inside function there? Well, the inside function would be x cubed. So we're going to let u equal x to the third power, right? Because that's implied to be in the function. Okay, so y equals sine of u, right? So the outside function is sine. Okay, so when we take the derivative of y with respect to u, it would be equal to, right, cosine of u times the derivative of u. Okay, so we'll replace u. So it'll be dy dx. So cosine of x cubed, and then times the derivative of u. So it'll be 3x squared. And that's good. Or we can move the 3x squared to the front. But either answer would be acceptable. All right, so moving forward, we're going to try not to use u substitution because it's just time consuming. But if you need to rely on that strategy, that's okay. So we try to identify what the inner function is, right? And we can see that the outer function would be, u to the 10th if we let u equal that expression I have highlighted. So, okay, so we're going to find the derivative using the chain rule, right? So it'd be 10 times the inner function to the 9th power, right, using the power rule, and then times the derivative of the inner function, what I've highlighted, which would be 18x squared plus 3. Okay, and we could simplify it a little bit. We could multiply the 10 to that binomial. So what is that? 180x squared plus 30? And then times what was left? Okay, okay, let's look at B. Okay, so B, anytime we see a root, we try to rewrite it to be to a power. So to the 1/2 power. All right. So the derivative of G. So we'll have to apply the chain rule here as well. So we got 1/2 times 5x squared plus 1 to the negative 1/2, and then times the derivative of the inner function, which is 10x. And then so we could multiply the 10x times 1/2 to clean it up a little bit. So this would be 5x times 5x squared plus 1 to the negative 1/2. And as always, you could rewrite it to fractional form if you want to, but not necessary, but just good to practice. Okay, so let's look at C. Okay, so C, remember cosecant squared x, this is the same as cosecant of x squared. So we can see the inner function is cosecant x, right? And so the outer function would be like u squared if we did u substitution. So, so the derivative of y with respect to x would be 2 times the inner function, cosecant x, to the first power. We don't have to write that, and then times the derivative of the inner function, cosecant x. So that'd be negative cosecant x, cotangent x. Okay, and then we can multiply the cosecant x's together. So we got negative 2 cosecant squared x, cotangent x. All right, and then D, we could use the quotient rule, or we could maybe rewrite it such that we could use the chain rule. So this is negative 7 times 2x minus 3 to the negative 2. So when we take the derivative with respect to x, right, so negative 2 to the front, so that makes it 14 times 2x minus 3 to the negative 3, right, and then times the derivative of the inner function times 2. Okay, so 14 times 2 is 28, and times 2x minus 3 to the negative 3. And we'll leave it like that. Okay, on this one, we have this function times that function. So we have to use the product rule, right? And in this function right here, we have to use the chain rule. So we have to use the chain rule and product rule. So we're going to start with the product rule. So that's, f prime times g plus fg prime. So, okay, so h prime of x would equal 2x times 3x cubed minus 5 to the third, and then plus x squared. And then here's where we'll use the chain rule. So I'll put this in brackets. Okay, so we'll move so keep in mind that is the inner function, what I've highlighted. So we'll move the 3 to be a coefficient, right? So 3 times 3x cubed minus 5 to the second power, and then times the derivative of the inner function, which would be 9x squared, right? So everything in brackets, that's using the chain rule on that second piece. Okay, so what can we clean up here? We can multiply x squared and the 9 and the 3 together, and that's about it. So that'd be, 27x to the 4th still have this up front. Okay, that's good. All right. All right, let's do, okay, the next one. Okay, so this one will require us to use the product rule as well. So we want to rewrite it to be sine of x times 1 minus x squared to the 1/2. Okay, so dy dx, right? So product rule again. So cosine x times 1 minus x squared to the 1/2, and then plus sine x, and then times the derivative of this, so that's the inner function, right? So we're going to use the chain rule here. So we'll move the 1/2 exponent to be coefficient, times 1 minus x squared to the negative 1/2, and then times the derivative of the inner function, so 1 minus x squared. So the derivative of that is minus 2x. Okay, so again, everything in the brackets is using the chain rule on the square root of 1 minus x squared. Okay, can we clean up anything? Yeah, we can. So the 2 times a half will cancel out to become 1. So we'll have minus x sine x times 1 minus x squared to the negative 1/2. And then nothing happened on that first term, so we'll leave it like this. Okay, I'm going to skip around. I'm going to skip 3. We'll work next time more with tables and finding the derivatives. Let's do 4a. Okay, so we see a root, so we want to rewrite this to have an exponent. So 3x cubed plus 4x all to the 2/5 power. Okay, so we'll have to use the chain rule here. And so, okay, so f prime of x will equal, okay, so the inner function is that part. So we got 2/5 being moved to the front times 3x cubed plus 4x to the negative 3/5, and then times the derivative of the inner function. So what is that? Okay, so what is that? 9x squared plus 4. Okay, and that's good. We could leave it like that, but let's practice putting this into a fraction. So it'd be 2 times 9x squared plus 4 in the numerator over 5 times the 5th root of 3x cubed plus 4x to the 3rd power. Because sometimes we have to evaluate derivatives, and it's good to put it in fractional form like that. All right, and then we'll skip part B. Okay, so here we have a equation where we'll need to do the quotient rule and the chain rule when we're finding the derivative of the denominator. Okay, so we're going to use the chain rule, and y'all know I like low d high minus high d low over low squared for remembering the quotient rule. Okay, so the derivative of y with respect to x would equal, well, okay, let's rewrite this function before we do that. So this would be x squared plus 4 to the 1/3. Okay, so give myself space. Okay, so dy dx is going to equal the low function times the derivative of the high function, which is 1, and then minus the high function, and then times the derivative of the denominator, right? The low function. And keep in mind, that's the inside function when we're doing the chain rule here. Okay, so we'll move the 1/3 to the front, of x squared plus 4 to the negative 2/3, and then times the derivative of the inside function, which is 2x. Okay, and then all of this is over the low function squared. So 1/3 squared. All right, so now we'll just simplify what we can. So we can drop that 1. X times 2x times the 1/3 we could do. So that's 2x squared over 3 times x squared plus 4 to the negative 2/3 all over x squared plus 4 to the 2/3. And we don't like a fraction within a fraction, so what could we do? We can multiply the numerator and denominator by 3. Okay, and that's okay to leave it like that. Okay, so on these next few, we're going to do the chain of the chain rule. The reason for this is because we have a function inside a function inside a function. So let me kind of illustrate this. So this we could rewrite as tangent of pi x, all to the 4th power. So the outside function is, u to the 4th, right? If we let the inside function be everything that's not highlighted. The middle function, right, is tangent, right? Tangent is inside u to the 4th. And then what's inside tangent? Well, it's pi x. So we'll have to do the chain of the chain here. Okay, so let's do this. So dy dx would equal, right? So the derivative of the outside function, 4, gets moved to the front, of tangent of pi x, right, to the 3rd power, right, times the derivative of tangent, which is secant squared of pi x, right, and then times the derivative of the inner function pi x, which is just pi. Okay, so we can't do anything with this, so we'll leave it like that. We could move the 4 pi to the front, and maybe we could delete the parentheses right there. Times secant squared of pi x. Yeah, that might make it look a little bit cleaner. Okay. All right, on this one we want to rewrite the equation to be to the 1/2 power. And then same thing, we're going to have to do the chain of the chain rule when we find the derivative. So let's recognize the outer function. Okay, so the outer function is u to the 1/2, right? The inner function is 7 minus sine of pi x cubed, and then the inner function is pi x cubed. Okay, so when we find the derivative, right, so we'll find the derivative of the outside function. Right, evaluate it at the inside function. Right, times the derivative of the middle function. So the derivative of 7 is 0, and the derivative of negative sine is negative cosine of pi x cubed, right? And then times the derivative of the inner function, right? What's in pink highlighted, which would be 3 pi x squared. And we will leave it like that because can't really do anything. You can make this like over 2. But this doesn't do anything for us. right? You could do that. But nothing canceled out or anything. Okay, the next one. So what do we have here? So the outside function is u cubed, right? So the whole function being cubed is the outside function. The middle function is the sine of 4t, and then the innermost function is 4t. So again, we're going to do the chain of the chain here. So let's do this. So f prime of t would equal 3 times sine of 4t to the second power times the derivative of sine of 4t, so this is cosine of 4t, right, times the derivative of the innermost function, 4t, which is 4. Right, and we do 3 times 4 pretty easily. And yeah, that's the derivative. Okay, on G, we're going to have to use the product rule here, but we'll go ahead and rewrite the root to be to the 1/2 power. All right, so we got that times that. So we're going to use the product rule and the chain rule. So the derivative of 2x cubed is 6x squared times 1 minus 2x squared times the half plus 2x cubed. And then we got to do the chain rule on that second function. So times 1/2, right, of 1 minus 2x squared to the negative 1/2 times the derivative, right, of the inner function, which is negative 4x, right? And we could clean that up a little bit, right? We could do, what is that going to be? Minus 8x to the 4th. Oh, but divided by 2, right? So it'd be minus, yeah, because the 2 and the 1/2 cancel. Right, so we're just going to multiply x cubed, negative 4x together. So minus 4x to the 4th, and times 1 minus 2x squared to the negative 1/2. And then that first term, nothing happens. Okay, so that's the derivative. All right, on 5, we want to find all the points on the graph of f of x for which the derivative equals 0, and for those which the derivative does not exist. Okay, so let's rewrite the function to be x squared minus 1 to the 2/3. All right, and so we want to find the derivative. So, okay, f prime of x would equal 2/3 x minus 1 to the negative 1/3, right? And apply the chain rule. So the times the derivative of the inner function is 2x. So we could clean this up. We could say, okay, this is 4x over 3 times the cube root of x. Oh, I forgot the square right there. X squared minus 1. Okay, and then we want to figure out where the derivative equals 0, right? And where it doesn't exist. Okay, so the derivative would equal 0 where the numerator equals 0, right? So that's where 4x equals 0. So that would make x equal to 0 if you solve that, right? Okay, so we want to find the points, right? So that implies we want the ordered pair. So, okay, we need to plug 0 into the original function. And so when we do that, we'll plug into the radical form. Okay, so this ends up being 1. So 0, 1 is where the derivative equals 0. Okay, and what else do we want to find? We want to find where the derivative doesn't exist. Okay, So the derivative does not exist where the denominator equals 0. So, okay. So we want to solve that. Okay, so if we divide both sides by 3, right, we'll have this. And then if we cube both sides, we'll have this. And then so x has to equal plus or minus 1 when you solve that. And so we want to plug in f of -1 and also f of 1 into the function, the original function. So when you do that, you know, the same function, you get 0. And if you do the same thing for 1, you also get 0. So -1, 0 and 1, 0 are where the derivative does not exist. Okay, last question. So find an equation of the tangent line of that graph at the point x equals pi. Okay, so we know how to find this. We got to find the derivative to find the slope. So the derivative, so the derivative of 2 sine x is 2 cosine x. And then the derivative of cosine 2x, we have to apply the chain rule here. So it would be minus sine of 2x times the derivative of the inner function, 2x, which is just 2. All right, so where do we want to evaluate the derivative at pi? So it'd be 2 cosine of pi minus 2 sine of 2 pi. Okay, so the cosine of pi is -1, right? So it'd be 2 times -1, and then sine of 2 pi is 0, so that'll just 0 out. So this ends up getting us a slope of -2. All right, and so what else do we need? We need the y-coordinate of this point. So that is finding f of pi. Okay, so let's see. Okay, so sine of pi is 0, and then cosine of 2 pi is 1, right? So the y-coordinate where this is happening is 1. Okay, so we can write the equation. So it'd be y minus 1 equals -2 times x minus pi. That's the equation of the tangent line at pi.